Good afternoon. I'm Dr. G. Deepika, ECE Department, Malla Reddy Engineering College for Women. So today I'm giving the lecture session on characteristic table and characteristic equation of SR, JK, D and T flip-flops. Next I am going to cover the excitation table of SR, JK, D and T flip-flops. So nowadays many students, they are getting confused when they are covering the topic of flip-flop conversions. That is, when they are converting from SR flip-flop to JK flip-flop, or SR to D, or JK to D, or JK to T flip-flops, some confusion is created among the students. So they are thinking that whether we should use the characteristic table or the excitation table for the conversion of the flip-flops. So in the conversion of the flip-flops, we need to use both these concepts for creating the conversion table. So we are using the characteristic table as well as we are using the excitation table in the conversion of the flip-flops. So first we'll go for the characteristic table of the flip-flops. So characteristic table, how you will define this characteristic table? So what is the information this table gives us? So characteristic table, it gives the information about the next state of the flip-flop based on the current state as well as the flip-flop inputs. So this characteristic equation, this characteristic table, it is basically derived from the truth table of the flip-flops only. So this characteristic table, it allows, that is, it gives many, it gives us details about the many operations done in the flip-flops, such as setting of the flip-flops, resetting of the flip-flops and toggling of the flip-flops based on the flip-flop inputs. So now we'll go for the characteristic table is completed. Now we'll see what is the characteristic equation. So this characteristic equation we are deriving from the characteristic table. So characteristic equation, this equation depicts the next state value by the combination of the present state as well as the flip-flop inputs. So this equation we are deriving by considering the present state values as well as the flip-flop input values. So first, characteristic table of SR flip-flop. So we will talk about the characteristic table of SR flip-flop. So in order to write the characteristic table of the SR flip-flop, so we have to write first present inputs, that is SR are the flip-flop inputs and QT represents the present state and Q of T plus 1 represents the next state. So this is the structure of the characteristic table of the SR flip-flop. So before going to the characteristic table in detail, so I have told that characteristic table is derived from the truth table. So first I will just recall the truth table of the SR flip-flop. So in the SR flip-flop we are writing as SR and Q. So when I am giving the SR inputs as 0, 0, now I am getting the output value as no change. When I am giving the S value as 0 and R value as 1, I am getting the output value as, that is, flip-flop is reset, output value is 0. Next, when I give the value of S as 1 and R as 0, now the flip-flop is set to set. So we say that when the S value is 1, the flip-flop is set, and when the S value is 0, the flip-flop is reset. Next, on the fourth condition, I am giving as both the S and R values are 1. Then the output condition, it is going into the forbidden state, or we say that it is a invalid state. So this is about the truth table of the SR flip-flop. So now we will use this truth table for deriving the characteristic table. So in the characteristic table, we are writing the present state values as 0, 1, 0, 1, 0, 1. So for every value of S and R, we are writing the twice the combinations of, what are the possible combinations for the flip-flops? 0, 1, 0, 0, 0, 1, 1, 0 and 1, 1. So I am writing the combinations for the SR flip-flop as twice as 0, 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1 and 1, 1. So first one, I am taking the first combination as S value is 0 and R value is 0. I am getting the Q of T plus 1, that is next state value as present state value only. That is, present state value is replicated in the next state. Next, when I am taking the value of S as both 0, next I am getting the value as 0 in the next state, that is flip-flop is reset. Next, when I am taking the value of S as both 1 and R value as both 0, I am getting in the next state as both ones, that is flip-flop is set. Next, fourth condition I am taking as both S values are 1 and both R values are 1. In that case, I am getting the don't care conditions, that is the invalid conditions. So this is the structure of the characteristic table of the SR flip-flop. Now I have to write the characteristic equation for this SR flip-flop. So how many inputs are there in the characteristic table? S, R and QT. These are the three inputs are there in the characteristic table, and Q of T plus 1 represents the output. So for the three inputs I have to draw the K-map. That is, I have to go for the three variable K-map. So now I have drawn the three variable K-map by considering the three inputs S, R and QT. Now I have to write the equation or characteristic equation for the next state, that is Q of T plus 1. So here after drawing the K-map, I got the values as S and R dash QT. So now I am writing the equation for the characteristic equation for the next state as Q of T plus 1 is equal to S plus R dash into Q of T. Like this, we will derive the characteristic table and the characteristic table for the characteristic equation for the SR flip-flop. Students, they should not get confused. It's a very easy method. So next we will go for the JK flip-flop. So in the JK flip-flop, so here just the characteristic table we are writing by changing the inputs, because we are designing the JK flip-flop. Instead of SR, here we are taking as a JK, same QT is the present input and Q of T plus 1 is the next input. Next, before going to the characteristic table, I want to recall the truth table of the JK flip-flop. So in the JK flip-flop, when both J and K inputs are 0, we are getting the output as no change. When J input is 0 and K input is 1, I am getting the, that is, we are making the flip-flop to reset. And when J is equal to 1 and K is equal to 0, the flip-flop is set. And when both J and K values are tied to logic 1, then we are getting into the toggle state. Toggle state means in the output, in the next state, we are getting the inversion of the present state condition. So whatever the value will be there in the present state, that will be inverted and it will be carried forward to the next state. So this, now we will speak about the characteristic table. So characteristic table means present state values we are taking as 0, 1, 0, 1, 0, 1 for all possible values of 0, 0, 0, 1, 1, 0 and 1, 1. So for the first combination of J and K values are 0. So that present state value will be continued in the next state. When both J values are 0, then the flip-flop is reset. That is Q of T plus 1 value is made 0. Next, when the J and K values are 1, then the flip-flop is set. That is next state value will be 1. That is flip-flop is set. And when both J and K values are 1, the J and K flip-flop will toggle. That is, here in the present state we are having the value of 0, 1, that is inverted and that is carried to the next state. That is, here 0, 1 is there, here 1, 0. So this condition we will call it as the toggle condition. Next, how to write the characteristic equation from the characteristic table. So how many inputs are there again in the characteristic table? There are three inputs, J, K and the present state J, K, Qt. These are the three inputs and only one output Q of T plus 1 is there. So for again we will go for the three variable K map J, K into Qt. So this again after mapping we'll write the characteristic equation for the next state Q of T plus 1 as J into Q of T, J into Q bar T plus K bar into Q of T. So this is the characteristic equation obtained for the JK flip-flop. Next, similarly D flip-flop characteristic table. So in the D flip-flop characteristic table, again we will recall the truth table of the D flip-flop. So whenever the D flip-flop means only one input will be there. So that is data input. So whatever the data we are giving to the D flip-flop, so that data will be replicated in the output. Suppose I am giving the value of D as 0. So that value will be shown in the output. That is, D is equal to 0 means output value is 0. D is equal to 1 means output value is 1. So now I will design the characteristic table by considering the present state and the next state conditions. So here how many inputs are there? So for the D flip-flop only one input is there, and here present state is the other input. Here only two inputs are there. So for the two inputs we will write the K-map for getting the characteristic equation for the next state. So here by mapping the two inputs D and Qn, I am writing the characteristic equation for the D flip-flop as D is equal to Q of n plus 1. Next, finally, I will go for the characteristic table of the T flip-flop. Again, before going to the characteristic table of the T flip-flop is nothing but the toggle flip-flop. We will recall the truth table of the T flip-flop. T flip-flop means only one input is there. So whatever the input is there, so that input will be carried. So when I am giving the input as 0 to the T flip-flop, in the output state I am getting the value as QT, that is present state value is continued in the next state value. Next, when I am giving the value as 1 to the T flip-flop, then the toggle condition will occur, that is Q of T plus 1 is equal to Q bar T, that is in the output present state value is inverted and is shown in the output. So next characteristic table, coming to characteristic table, here also we will be taking the one input and Q of n represents the present state, Q of n plus 1 represents the next state. So here as I am taking the T value as 0, so output value is, so here I am getting as no change, that is Q of T, whatever the value of Q of T, that is shown in the next state condition. Next, when I am taking the value of T as 1, that is toggle condition will occur, that is the value present in the present state condition is inverted and it is shown in the next state. That is in the present state we are having the value as 0, 1 and it is shown as 1, 0 in the next state. So here there are two inputs are there. So we will draw the K-map for the two variables only, T versus Qn. Now I am getting the characteristic equation for the T flip-flop as Q of n plus 1 is equal to T bar into Q of n plus T into Qn bar. So these are the characteristic tables and characteristic equations of SR flip-flop, JK flip-flop, D flip-flop and the T flip-flop. Now we have understood what is characteristic table and what is characteristic equation. Next, thank you.